Welcome to class 4 of Java. In this class 4 we are going to understand keywords in Java and data types in Java. Okay, so we are going to understand data types in Java. Okay, so first of all we are going to understand about keywords in Java. What are keywords? Keywords are the reserved words whose meanings are predefined in the language. Means keywords are nothing but main words of the language, and each main word have a predefined meaning. How many keywords are main words present in the Java 17 version? There are 51 keywords are present, like abstract, asset, boolean, break, byte. Like this, when we come here, there are 51 keywords are present. Now these keywords, each keyword have a predefined meaning, like abstract have a meaning, asset have a meaning, char have a meaning, for have a meaning, if have a meaning. Like this, predefined meanings are present in the language. That is what we say, keywords are the reserved words whose meanings are predefined in the language. Means these meanings are already present in the language, and using these keywords we write and understand the Java programs. So without using these keywords we can't write or understand what programs. Therefore keywords are one of the important parts of the language. Okay, keywords are the one of the main part of the language. Okay, so this is, so when we come to the Java 17 there are 51 keywords are present, but when we come to the latest version of the Java there are 67 keywords are present. Okay, but all that keywords are not that much necessary. Okay, so but these 50 even keywords are very important in programming. So I have prepared some notes, you can go through this particular thing. So number of keywords will change from version to version. So when we are coming to the Java 17, Java 17 is support what long term support. Means the Oracle Corporation will support this particular uh, uh, Java 17 for a long time. Means in the future also, if any problems comes in this particular, any bugs comes in this particular Java 17, they will rectify and they will release. Means they will support any problem that comes in this particular software. So that is what we call as long term support. Okay, so better we as I am using Java 17, then these keywords only we are going to understand in the further coming classes. Okay, then one thing that is very important to note in these keywords, please. Okay, that is first one is true, false and null are not keywords, please. How many keywords are present? 51 keywords are present, and these particular true, false and null are not the keywords. They are what? Literals. Literals means they are constants. They are constants. Okay, so therefore these are not variables, they are what? Constants. Means how they are going to be used, let me give you some example if you want. So example I can give you. For example, I can say that string name is equal to null, I can write. So null is a constant value, so name is what? Null. Null means empty. So for representing an empty value we generally use what? Null. Okay, similarly we are going to use boolean. Okay, so let's say that flag is equal to true. Like this we can use. So the flag value is what? True. So like this, null, true and false are what? Constants. We are going to understand this particular thing in the further coming classes. Okay, right. Another important point regarding this particular keywords is the variable names, class names, method names should not be same as what? Keywords in C. Example, let me tell you the examples here. Example, I cannot write a variable integer. Okay, integer if is equal to 12. No, I should not write. Okay, I cannot use here float. Okay, float. Something called as class is equal to, okay, 5.66. Okay, this is wrong. Why? Because if and class are what? Keywords. You can see here. So if is a keyword, class is a keyword. Okay, so like this it should not be. Okay, so therefore suppose I write a function, I cannot write something called as abstract function. I should not write here. This is a like function, I should not write. Why? Abstract is also one of the keywords of what? Java. So like this, all these are wrong. So this is what? Error. This is also error. Okay, error. And abstract, this is also error. Like this, variable names. Okay, variable names, like this, variable names or function names or maybe class names. Class, I cannot write here something called as one of the keyword we will take otherwise here. Okay, for example, while. Okay, control C, while is a keyword, so I cannot write here the keyword as what, like this. I should not write the keyword. Okay, this keyword is not, so this is also gives what, error. Okay, so this is what I will say, that your variable names or method function names or method names and class names should not be same as keywords of Java. So you can use other names, but we should not use that particular keywords. Okay, so this is what we have completed keywords in Java. So keywords are the reserved words whose meanings are already present in the language, and using these keywords we write and understand the programs. So we are going to understand the meanings of these keywords in the further coming classes, one after the other. Okay, now the second thing that we are going to understand is data types in what, Java. So what are the data types? Generally data types are used to create variables. Okay, data types are used to create variables which can store what, values. Okay, so I can give data types can be used to create variables that can store constant values. Okay, this is what happens is, there are two types of variables are there. Okay, there are two types of data types are there, sorry. So there are two types of data types in Java. One is primitive data type, next one is what, non-primitive data types. Like this we have two types of data types are present. First of all, we are going to understand primitive data types. So there are 8 primitive data types are present, like character, byte, short, int, long, float, and double. So how these particular data types are organized in the Java, so that we are going to understand with the help of this picture. So when we come to the data types, this data type is divided into two categories. One is primitive, next one is what, non-primitive. When we come to the primitive, what happened here, this is Boolean, okay, numeric. They are divided into two. One is primitive data types are divided into two, Boolean and what, numeric. Boolean means Boolean data type only in this category. When we come to the numeric category, there are two data types exist again, sub data types. One is character and integral. Okay, in character there is a data type called as char. So char comes under what, numeric category only. Okay, so then integral contains what, numbers. So integral means numbers. The numbers category again two, that is what, integer. Next one is what, floating point. When we come to the integers, what are integers? Integers are the numbers without any decimal points. Okay, so in the integer category there are four data types are there: byte, short, int, long. And when we come to the floating point means numbers with points. So numbers can have what, decimal points. So this floating point data types are two, float and what, double. These comes under what, primitive data types. Okay, and when we come to the non-primitive data types, they are string, arrays, etc. Okay, this is what comes under. We will discuss this one later on. So first of all, you understand about primitive data types. So when we come to the primitive data types, these primitive data types, whatever the 8 data types are there, these data types now we are going to understand in depth what is the size of the data type, what is the value that it can store. In that way we are going to understand. So this is a list of 8 data types. Okay, so byte, short, int, long, float, double, and Boolean, char. Okay, we understand one after the other. First of all, we come to the byte. Okay, we'll come to the byte. So understand carefully first of all categories. Okay, see, this is a numeric category. In the numeric category we have character and what, integral. Integral contains what, all these particular data types, integer and float data types. So you remember this category please, because in the further programming we have to use these particular categories. Okay, we have to understand very clearly, right? Fine. Now what happens is data type. Byte data type we are going to understand. What is byte? Byte data type size is what, 1 byte, and it can store whole numbers from -128 to +127. So what is the meaning of this particular statement, sir? So let us understand this particular thing in depth now. Okay, so let me explain this one in depth. Here generally to understand that particular thing we have to understand about memory. Okay, memory we have to understand please. So let me explain about memory first of all. So your computer have what, memory, that is what we call as RAM, internal memory of computer. This is the memory, internal memory of computer is what, RAM, which is random access memory. This memory is divided into what? Cells like this. The memory is divided into what? Cells. These are called as memory cells, what we called as. Okay, and each cell have a number. Okay, each cell have a number. Let me say that the number is like 101 cell address, 102, 103. Actually the cell addresses starts from 1 only, but generally I am writing from 101. Okay, so like this it will have the cell addresses. So these addresses are called as what? Cell addresses. Okay, cell addresses. This is what happens, it's cell addresses. Okay, each cell have a number. That number is called as cell address, and cell addresses always will be sequential. Okay, this is. Now what happens is your any data, okay, any data is stored in this particular cells only. So the data is stores in what? The cells. Data means what? It may be a character data, it can be an integer, it can be float. Okay, like this, any data is stored in this particular cells. Then one cell can store how much amount of information. That is what we have to understand now. Okay, so we have to understand one cell can store how much information. Okay, this is what important. So one cell can store 1 byte of information. Okay, 1 byte of information, or what we call as data, 1 byte of data. Then what is 1 byte? Now the question comes here, it's what is 1 byte? Okay, so 1 byte is equal to 8 bits. Okay, a bit can be either 0 or what? 1. Bit can be either 0 or 1. So the collection of 8 zeros and ones is called as what? Sorry, the collection of 8 zeros and ones is called as what? 1 byte. Is it clear? So like this, in the computer, information is measured in what? Bytes, and byte is equal to what? 8 bits. So we don't want to go in depth of that particular thing. Okay, so overview understand please. Now somebody asks, what is that? The 0 and 1. 0 means off, 1 means what? On. Okay, off and on. Because computer is an electronic device. Computer is an electronic device which understand everything in the form of what? Zeros and ones. Okay, such ones and zeros language is called as what? Binary language. So which language it is? Binary language, or what we call as machine language. So in this particular binary language or machine language, only zeros and ones will exist. In this language only zeros and ones exist. So any hardware, any machine, any electronic device understand only ones and zeros. That is, 0 means what? Off, 1 means what? On. Okay, so like this. So the collection of 8 zeros and ones is called as 1 byte. Okay, 1 byte. This is what happens here. It is. So one cell can store how much information? 1 byte. 1 byte means how many bits? 8 bits. Okay, so on this basis what happens here? It is, on this basis what happened? Let us say that, okay, a cell is divided into, okay, a cell, when we come to the cell, a cell is divided into 8 parts again please. Okay, 1 2 3 4 5 6, okay, 7 8, let's say that. So, like this, a cell is divided into what? 8 parts. Okay, and in this particular cell, data is stored in the form of what? Zeros and ones. Like this, the data is stored in the form of what? Zeros and ones, like this. Okay, so like this, in the memory cell, any data is stored in the form of what? Zeros and ones. Okay, so this is what happens. So once again I tell you please, the internal memory of computer is RAM, random access memory, which is a collection of cells, and each cell can store 1 byte of information. 1 byte means what? 8 bits. Means one cell can store 8 bits. And how it is going to store means, the cell is divided into 8 parts again. In this, each part of this particular cell stores either 0 or 1. Okay, so this is how the information stored in what? The computer's memory. Now let me paste this particular thing in the notes here. So let me copy and paste over here please. This is what the thing here it is. Okay, this is what we have understood about the memory. Now somewhat again understand this one. Let me erase this one please. Let me erase. Okay, fine. Now, as we have discussed that a memory is a collection of cells where the information is stored in the form of zeros and ones. Now, we'll continue now. So, one cell can store how much information? Okay, one cell can store how much value? Okay, how much value? That is what how much value it can store. That is what we have to calculate now. How to calculate? Let us understand this particular thing. Okay, let me take a cell, please. This is a cell. Okay, this is a cell. So 1 2 3 4 5 6 7 8 parts. Okay, so when we come to the cell, one memory cell contains what? 8 parts. This is what we call as last bit. What we call as last bit. So last bit store sign, please. Okay, last bit stores what? Sign. The sign can be, understand carefully, the sign can be either plus or what? Minus. Plus means what? 0. Minus means what? 1. So in this last bit it stores either 0 or 1. 0 means positive, 1 means what? Negative. This is what? Positive and what? Negative. Okay, so this is what the meaning of this last bit. Now what happens to the remaining 7 bits? Okay, remaining 7 bits store value. 7 bits store what? Value. 7 bits store what? Value. So how much value that it can store? How much I can say that how much information that it can store in 7 bits. Okay, how you calculate this? How you calculate this? This is what now I am going to explain. So I am talking about only one cell, please. So this will be applied to what? 2 cells, 3 cells and 4 cells and etc. Okay, so I am explaining for only one cell of memory. Okay, right. So let us understand for small thing like what? 3 bits. Let's say that 3 bits. Okay, for 3 bits I am going to explain first of all. 3 bits. So 3 bits can store how much value? Okay, not 7 bits. I will make it 3 bits. Only positive I am going to explain. No negative values. Only positive positive things that I am going to explain. Let us say that in this particular cell parts, it's the information is stored in the form of zeros and ones only. Okay, so I am going to store in what? Binary language. See, 0 0 0 it can store, which is nothing but 0. So the binary value of 0 is what? 0 0 0. Okay, then 0 0 1 is nothing but the 1. Okay, 0 1 0 is nothing but 2. So 2 binary value is 0 1 0. Similarly 3 is what? 0 1 1. Okay, this is what? 3. 1 0 0 is what? 4. Okay, then 1 0 1 is nothing but 5. 1 1 0 is nothing but 6. 1 1 1 is nothing but 7. Is that clear? So like this we can store in these three bits up to 7 only we can store. We cannot store more than 7. So this is what. So how, sir? How it is, sir? Means I will tell you simple. For example, we'll talk about 5. So how this particular 5 is going to be 101. So 5, any value divided by 2, because binary language. Binary language means what? Binary base is 2. Okay, so let us understand that also, please. Binary base is 2. Okay, octal base is 8, hexadecimal base is 16, and decimal base is what? 10. So the base. Okay, so as it is a binary value, this particular decimal value we want to convert into binary, therefore we have divided with what? 2. Okay, so how many times it goes? 2 2s are 4 and it is 1 left. 2 1s are 2, nothing is left, therefore 0. 2 not divisible, therefore 1 is carried as not divisible, therefore 0, and 1 is carried as what? Remainder 1. Okay, once you get 0, please stop the procedure, stop the division and write down from bottom to top, that is 101. So like this 5 is 101. Similarly you can calculate for the other things. Okay, right. So in this particular 3 bits, please, in these 3 bits, what happens here? It is up to 7 only we can store. Sir, what happens if I store 8, sir? Let us calculate 8. See, 8 does not fit in that 3 bits because 2 4s are 8, nothing is left. 0, 2 2s are 4. Okay, nothing is left. 0, 2 1s are 2. Okay, nothing is left. 0, and not divisible, therefore 0, and 1 is carried as remainder. Okay, Now write down from bottom to top. What is that? 1 0 0 0. So how many bits you are getting? 4 bits. 4 bits cannot store in the 3 bits. That is why I am stopping here 7. Okay. So in 3 bits, how much value we can store? 0 to 0 to 2 power 3 bits minus 1. Okay. So what I am doing, please understand, please. In 3 bits, how much value it can store? The positive value 0, 0 to 2 power 3 minus 1. 2 is a base of binary. 3 is number of bits, 1, 2, 3 bits, and minus 1. Why we are giving minus 1 here, please? 2 to the power of 3 is 8, 8 minus 1 is 7. So you got a 7 or not? Okay. So why we are giving minus 1 means, as it is starting from 0, the 8th number will be 7. Okay, 8th number will be 7. That is why we are I am giving here 2 to the power of 3 minus 1. Okay, as it is starting from 0, now here we have to reduce 1. So that is what. So in 3 bits, 0 to 2 to the power of 3 minus 1, it is storing. Similarly, in 7 bits, how much value it can store? In 7 bits, how much value it can store? That is what now we have to write it. Okay, so let me write that particular thing. Let me write here. So but I have to write a positive as well as negative number. Okay, because in these cells, positive as well as negative numbers it will store. So minus means minus 2 power. How many bits are there? 7 bits. 2 plus 2 power 7 minus 1 we have to write here. Okay, so how much value it will be now? 2 to the power of 7 means how much? Minus 128. 2 plus, okay, plus 127 only. 2 power 7 in how much? 128. Minus 1 means 127. This is the value. So in 7 bits, how much value that you can store? Minimum and maximum is minus 128 to plus 127. You calculate. If you want, you can calculate, please. 127 divided by 2, you do it. You will get 7 ones you will get. Okay. So like this. So 127, the maximum number of bits is 7 only. So here it will fit 7. Okay. So this is what happens here. It is fine. So in 7 bits, it can store a value minus 128 to plus 127. If you want to represent in binary, you can write 2 to the power of 7 bits negative 2 plus 2 to the power of 7 bits minus 1. This is the minimum value, and this is the maximum value that it can store in the one cell of memory. Okay, do you understand one cell of memory? Similarly, it will apply for 2 cells also. 2 cells means what? 2 cells means 8 plus 8, 16 bits it will be. Okay, I will tell you that particular thing also in the next coming class. Okay, so therefore let me save this particular thing and I paste over here. Okay, right, this is what happens here. So this is what. Okay, fine. Now we'll come to, okay, this data types. So tell me now, byte data type. Byte occupies how many? What's the size of the byte? Is 1 byte, and stores what's the number? In 1 byte, how much information we can store? Minus 128 to plus 127. Okay, that's nothing but what we can say, that minus, okay, let me write here, minus 2 power. Okay, 2 power, how we write here means like this I write. Okay, 2 power, what is that? Is minus 2 power 7 2, okay, 2 plus 2 power, okay, 7 minus 1. This is how we can write it. Is that clear now? Okay, right. Similarly, now tell me the short. Short is how many bytes, please? 2 bytes. Now tell me in 2 bytes how much information that we can store. Okay, so or I will tell you, otherwise here I write how much information that you can store. Okay, can anybody guess it, please? Okay, let me say that. So 2 to the power of 2 bytes means what? 2 bytes means what? Let me give you that particular thing. Okay, so let me explain. So erase here, erase. Now we'll say 2 cells. Okay, 2 cells. What is the 2 cells? This is what the 2 cells. Okay, 2 cells. This is address assume 101. This is address assume 102. So again, each cell is divided into how many parts? 8 parts. Let me draw that particular thing, please. Okay, 8 parts. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, so what happens is this last bit, okay, this last bit again, last bit stores what? Stores what? Sign. that is positive or negative. Positive means 0, negative means 1. And remaining how many left? 8 plus 8, 16. 16, 1 is left, used for what sign? Therefore left is how many? 15. 15 bits store value. Okay, store value. Then how can you say how much value that it can be stored? Okay, means minus 2 power 15, 2 plus 2 power 15 minus 1. So if you convert this particular thing into a value, then it will be 32,768 2 plus 32,767. This is the value. Okay, so this is what okay, this is what I'll paste it. See, this is what actually it is present over here. Short is 2 bytes, stores what? The whole numbers, this one. Okay, so I can write the statement over here if you want. What is that, please? Yeah, please, minus 2 power how much? 15 2 okay, minus 2 power, okay, minus 2 power 15 minus 1. Okay, this is the value thing. See, this is what happens with it. Fine. Similarly 4 bytes means same, similarly this one. So how can we write this one, please? So tell me, how can I write, please? How can I write this particular one? Yeah, see, yeah, minus 2 power 15, no, 4 bytes means what? 4 bytes, 1 byte is equal to 8 bits, means 8 4s are 32. 32 means 1 is for what? 1 is for what? Sign. Therefore how much left? 31. Okay, again this is also 2 power 31 minus 1. Okay, and the value is this much value. Okay, so you have to remember this one. Similarly, okay, then long, tell me long. Okay, long. Okay, long, how can you write the long size, please? How much value it can store in binary? How can you represent? That is 8 bytes. 8 bytes means 1 byte is equal to 8 bits. 8 8 is 64. 64 means what? 2 to the power of 64 means what? 63. Okay, and this is also 63 minus 1 and this is the value that will store. Okay, right. And when we come to the float is what? 4 bytes. See, this float is nothing but stores decimal points. Okay, so generally float stores what? 6 decimal points. Okay, 6 decimal points it can store. We cannot write range like this, please, because it will be in the what we call as a lot of fractions will be there, precision will be there, so that therefore we should not write. Okay, in scientific notation we have to write it, but is not required over here. Okay, float is 4 bytes which can store up to 6 decimal points. Okay, then double is there. Double is what? 8 bytes, and it can store what? 15 decimal points it can store. Okay, so this is what float and double can store points. Okay, float can store only 6 decimal points, and when we come to this particular thing, 15 decimal points. Okay, Boolean data type is only one bit, stores either true or what? False. True or false. So character is how many bytes? 2 bytes. Same, 2 bytes. Okay, we will discuss this particular character at the end. Okay, separately we are going to understand this is also right. Fine. So we have understood what? Now the basic numeric data types: byte, short, int, long, float and double. So remember the sizes, please. Byte is 1 byte, short is 2 byte size, integer is 4 bytes, long is 8 bytes, float is 4 bytes, double is 8 bytes. Okay, right. Then right, this is what. Now how to create variables? Simple, like C language. So integer data type, integer a is equal to 12, like this. Okay, if I want to make double, b is equal to, okay, 44.55, like this we can write. Is that clear? Right, if you want to write byte, no problem. Byte variable. So byte, okay, byte some x is equal to okay 21, like this we can write the variables, because all are numeric variables only. Okay, right. So this is what the numeric data types we have understood. Now we are going to understand something called as what? Boolean. Okay, first then we understand about what? Boolean data type. What is the Boolean data type? Let us understand that. Okay, let us say that let me copy this particular thing also, please. Right, let me copy paste it for your for reference. Okay, right, full. Good. Now what happens with the Boolean data type? Okay, so let us understand the Boolean in this way, right? So let me erase this one. So I can say that Boolean variables means like this. Okay, Boolean something called as flag. Okay, flag is equal to true. Okay, so boolean can store what, can store true or false, true or what, false. Now the point is, what is true? True means 1, okay, false means 0. So how many bits are required for this particular thing? One bit is enough. One bit is enough to store this particular value. So therefore boolean variables, okay. So remember please, flag is going to occupy 1 byte, but it can store only 1 bit. 1 bit it is going to occupy, only 1 bit it is going to occupy. So generally we say boolean size is what, 1 bit, okay. But 1 byte will be allotted. In that 1 byte, what happens? In that 1 byte, what happens? It will occupy only 1 bit, okay. 1 bit it will store, okay. This is what you remember, please. Right, boolean. So this is about boolean, okay. Fine. Next, now we are going now, and I would like to give you some more examples, please. Some more examples I would like to give on this particular thing, right? So let us understand, erase it. Now let us say that boolean, let us say boolean, okay, flag, okay, flag, okay, flag. Now I say flag is equal to, okay, 10 less than 20 I am giving, like this. What is the answer? So 10 less than 20 is true, okay, you will get true. Therefore true is stored into the flag. Therefore what is the flag is? Flag, if you print, you will get true only, not 1 you will get true only in Java, okay. So similarly I give flag is equal to, okay, so 10 is greater than 20, 10 is greater than 20, 10 is greater than 20 is false. Therefore Java will give the result as false, which will be assigned here. Therefore flag is equal to what? False. This is what, FALAC, false it will be. So if you print the flag value, it will give true, flag value false. So it will not give 1 and 0, but it will give you true, false only, okay. So this is what you have to remember. Now we are going to understand about character. Yes, the character is very, very, very important, okay. So what about character data type? This is character data type, okay. So the thing here it is, we have Unicodes, right? Unicodes. We have to understand what is Unicodes. So generally when we come to the Unicodes, okay, Unicodes are what? Unicodes, total codes how many? Okay, Unicodes, total Unicodes are what? Okay, 65,535, please. 65,535. Okay, what is the range? Range is equal to 0 to, okay, sorry, this is 36. Okay, when we come to the range, it is what? 65,535. okay, starts from 0. As it starts from 0, the end value will be 1, will be here reduced, okay, right. So this is what. Now what do you mean by this Unicodes? Okay, Unicodes are nothing but, simply I can say that Unicodes, okay, Unicodes are the numbers given to letters of all languages. Language means human languages, okay. So let us take example, right? Let us take example. When we come to the English language, okay, English language codes will be 0 to 255, and these codes are called as what? ASCII codes, please. ASCII codes, okay. So ASCII codes is a part of Unicodes, please, okay, right. Then other languages, when you come to the other languages codes starts from 256, please, 256 to till 65,535. Okay, this is other language, like what? Like Telugu, Hindi, okay, like Chinese, Japanese, French, Dutch, like this. Other language codes will be between what? 256 to this one. Okay, so like this, what happens is each language, any letter in the human languages is given one number in computer science. That number is called as what? Unicodes. The total codes is this much and the range is this one. Okay. So when we come to the English language codes are called as ASCII codes. American Standard Code for Information Interchange. Means this is American English language. Letters can be converted into machine language, and machine language can be converted into English language letters. with the help of these codes. Okay, how we are going to understand now. So what is the importance of these codes? Okay, through these codes, okay, through these codes, okay, these codes, okay, codes, computer translates, transforms, okay, translates, I will say that, translates, okay, translates english english language to English language to machine language, please. Machine language will translate, that is zeros uh, zeros and ones, okay, zeros and ones, like this. Okay, how, sir, how it is possible? Let us say, first of all, we have to understand codes. Like capital A is what? 65. Okay, then capital B is what? 66. Like this, if you go on, when we quote the capital Z will be 90. Okay, similarly, when you come to the small a is what? 97. Okay, small b is 98. Like this, goes on. Now small z is equal to 122, like this. Okay, these codes are there. Then 0 is what? 48. Okay, 48. Okay, 1 is 57. 1 is 57. 57. Okay, 57. Sorry, 1 is what? 48, 49, 49, 49. Okay, right. Like this, continue it. Okay, up to 9. 9 will be 57. 57. Okay, so now I am talking about English language codes. If you talk about English language codes, ASCII codes, okay, like this, each letter in the English language is given what? These codes. What about the remaining, sir? 65 to 90 you are saying. What about the before this particular value, like 0, 1, 2, 3, 4, 5 codes? What are the, that is what I mean to say is remaining, okay, remaining codes are related to let me say that special symbol codes, special symbols, special symbols, like plus, okay, minus, star, okay, like this, some, okay, etc. So remaining codes, whatever the remaining codes other than these, that particular codes are related to special symbols that I didn't remember, and is not required. Okay, but these codes you have to remember, please. You have to remember these codes, very very important. Okay, so other language codes also I cannot give you that. If you want, you can go to the Google, please. Okay, so but it falls between 256 to this one. Okay, so now I am going to explain how this English language is converted into binary language, and binary language to what, this English language. I am going to show you an example. Okay, let us understand now here. Okay, so therefore, if I give like this character, okay, what's the character size, please? Okay, once again understand, please. What's the size of the character data type? The character data type size is 2 bytes, please. 2 bytes, and stores a single letter. Okay, letter are what? ASCII value. Okay, so let us say how it is going to store ASCII value in character variables. That is what now I am explaining. Okay, character ch is equal to a, I am giving. Okay, ch is equal to a. Okay, now what is the size of character is 2 bytes. Therefore 2 bytes is assigned to ch is nothing but how many bytes? 2 bytes. Okay, so this is what? 2 bytes. Again, 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8, like this. So the addresses of the cells are 201 and 202, assume. So what happens is, the A, which is what? English, is converted into what? The binary language through what? ASCII code. ASCII code. What's the ASCII code I have given? A is what? 65. So this is what we called as ASCII code. ASCII code it will translate. So whenever you type A, the A is converted into ASCII code by the computer, and this 65 is converted into binary language. It is 1 1 2 3 4 5 1. So already I know that is what I am writing here. This is what? Binary language or machine language of 65. Like this, whenever you type A, that will be translated into byte ASCII code. That ASCII code will be converted into binary language, and this binary language will be stored into the variable. Okay, so like this, it is going to store the letters, please. Okay, so this is 1 1 2 3 4 5 1, and remaining things are always what? Zeros only. Got it clear? Right. So this is how it is going to work, please. So any letter that you give, please, any letter that you give, I repeat please, any single letter that you store in the character variable will be converted into binary language, and this binary language will be stored into the variable. So how these letters are converted into binary language means through ASCII codes, through Unicodes, okay, with the help of these numbers only it will be translated. So you can do, if you want, you can do 65 divided by 2, you calculate, you will get this particular number, okay. So this is, so control, okay, this is what I am going to copy as a reference to you, okay, right. This is what control S, save it, okay, fine. Next, I'll continue further. So there will be a small question, okay, what is that is, let's say, sir, what happens, what if, what is happening here, character ch is equal to a, you are saying, sir, no problem, but ch is going to occupy 2 bytes, let's say that 201, 202 cells. A, ASCII codes will store in only one cell, the remaining cell, the one more cell will be empty cell, okay. So it is going to store the ASCII code here, and the remaining cell will be what, empty. So when you are storing English letters into the variable, one cell will be empty, that is what you remember. But when we store other languages, for example, x is equal to, I store a Hindi letter like A. Now this x is going to occupy 2 bytes, okay, 2 bytes, okay, which is going to occupy the value in 2 cells, okay, except English language, any other language letter will occupy 2 bytes. This is what you remember, okay, because the ASCII code is the ASCII code for this particular Hindi letter I is what is a bigger value, and which gets what, more than 8 bits. That is why it's going to occupy 2 bytes, okay. This is a small thing that you remember, okay, fine. So like this we have completed data types, okay, that is what we have completed, data types, okay, and we understand how can we create a variables. Let's say, so string, so let us say that right now I am going to explain about what non-primitive data types. Second one is non-primitive data types. Now so far we have understood what primitive data types, please, okay. So far we have understood about primitive data types. These primitive data types we have understood, like what, boolean, okay, char, byte, short, int, long, float, double. Now non-primitive data types are like arrays and strings, okay. So let me first tell you one of the non-primitive data type, like what string I am going to explain, please, okay. Like string, like string I would like to explain, because this is a common thing that I am going to use, okay, in the programming. String means what, string, okay. A string is a sequence of characters, okay, okay, sequence, or what we can say, group of characters, okay, group of characters. So let me give you an example on strings, please. The examples on string here, it is like let's say that Kumar, this is what a string. A string can also be like this, like for example, WRANGL, Warangal, okay, Warangal hyphen, like say 50506002, like this we can give, okay, no problem, okay. A string can be a combination of alpha as well as what, numeric and special symbols, clear, right. So if you want to store the string values in Java, then we have to create a variable like what, string name is equal to, let's say, Kumar, like this we have to store, okay. So this is what string. What is a string? A string is a class, okay. So in Java, string is a predefined class, okay. A class is a data type. Assume that class is a non-primitive data type, okay. So like this, string is a class, okay, and you see that S should be capital, please, because it is predefined and it is S is a capital. Now string name is equal to Kumar, like this we can give the strings, okay. String should be kept in double quotes, please. String constant should be kept in double quotes. This is what you have to remember, fine. So finally I would like to conclude that how to create variables, okay, how to create variables. So let me give you some examples how to create variables. For example, okay, I say integer roll number, okay, roll number is equal to 25, okay, fine. Next I can say that okay, double average is equal to 99.99, okay. Then character grade is equal to B, let's say that, okay, like this we can say, okay. And if you want the name of the student, then I can say that string name is equal to, okay, name is equal to King, let's say that King, okay. This is what happens. Like this we can create the variables, which is very similar to that of C language, okay. So remember, this is what the data types we have understood till now. So the data types are used to create what? Variables, and in that variables we store values. And data types are categorized into two: primitive and what? Non-primitive. And primitive are these data types, non-primitive are these data types. And I explained only regarding string. Is it okay? Right?